Hey guys, welcome back everybody. So in this video, we are going to talk about the router ID concept. So there is a mini use case of the router ID. If you see in the BGP, the router ID is a different use case. The EIGRP has router ID has a different use case. OSPF also has a different use case, right? So let's start with the lecture. So before I'm going to explain the router ID concept, first let me give you the example of the name. So let's see, there is a one guy. Okay, this guy name is Amit, right? So maybe I can say Amit Soni, right? So if you're gonna call this person, right? So take example, this is the XYZ person. And if this XYZ person gonna call this guy, how they will call it? They will call it Amit. Or maybe the Amit Soni, they will call it. Take another example. There's another person whose name is Punit Pandey, right? So if this guy, the XYZ person is gonna call the Punit, how they will call it? By using the name. He said, hey, Punit, come here over here, right? Same way, another person is there. Take example. We have a this beautiful girl. This name is maybe Nidhi, right? So if this XYZ is gonna call this girl, how they will call it? They will say that, hey Nidhi, come over here, right? So in a real world, if you see, we have a name, and based on the name, we can call the person. Same thing, we have a laptop. Laptop is a name. Mobile phone is a name, right? Router is a name. Switch is a name, right? CCNA, it's a topic, one of the syllabus name. CCNP is one of the syllabus names. Cisco is a company name. Juniper is a company name. Same way, in a networking world, what happened? If you put the router over there, take example, this is the icon of the router, right? This is the another icon of the router. This is another icon of the router. So if this is the network engineer, this is the XYZ network engineer. So this network engineer, just for the own benefit, right? Just for the own identification, they can put the logos over there, say that, hey, this is the router one. This is the router two. They can put the one logo, right? And this is router three. A tag, we can call it in a simple language, encapsulation .1q tag, VLAN tag. So we can put the tag over there. This is router one, this is router two, router three. That's for the network engineer. So any of the network engineers coming, this is for the XYZ. For example, any another network engineer is coming, based on the logo, they can identify, okay, this is router one that is connected with the internet. That's router two that's connected with the LAN network. And router three that's connecting with the another LAN network, right? But what happened if I'm going to run the any routing protocol? Let's take example of the EIGRP. So if I'm going to run the EIGRP routing protocol, right? So I have a EIGRP domain over there, EIGRP number one. So in this EIGRP domain, how does the EIGRP protocol is because this is the another person, right? This is the EIGRP protocol is another person. How does this protocol is going to identify this router one? This guy has identified because I put the name because this is the living thing, right? This guy is totally non-living thing. How does this person is going to identify it? So in that case, what happened? We need to bring some identifier over there, and that identifier is called as a router ID. So basically, a router ID is just a name of the router, right? It's just a name of the router. Only the thing is that this name has some format, and that format is called as a IPv4 format. The format of the router ID is the IPv4 format, for example, x.x.x.x.x. So this is the format that you have to use. Like we have a format, right? I can put the Amit Tanbar, Punit Pandey, or maybe anything. So we need to put the name of the router, and the name of the router you have to represent in this format. So I can say that, okay, the router ID for this guy, according to the EIGRP protocol, I can put this guy's router ID will be 1.1.1. I can put any number. So this is the range of the router ID we have. We start with the 0.0.0.0.0 to the 255.255.255.255. So this is the range of the router ID, but you cannot use this two IP addresses for the router ID. You have to use with the 0.0.0.1 with the 254, 255.255.254. So this is the actual range you can use it, but this two router ID is totally reserved. You cannot use this router ID on the router side. So I can put the any number, I can put the 1.1, I can put the 2.2.2.2.2, and I can put the 3.3.3.3.3. So EIGRP protocol is going to identify, okay, this is this route. For example, I have a one route 10.0.0.0.0, and I have a connectivity between the router 2 and router 3 as well. So router 1 is going to send this information to the router 2, the 10.0.0.0, and at the same time router 2 is also going to send this information to router 3. router 2 and router 3 will install this information in the topology table that EIGRP has. So in the EIGRP topology table, you can see that, okay, this 10.0.0.0 route is coming with the router ID 1.1.1. It means that he's the person that is generating this route. Same way on R3 also you have a topology table. So now R3 you can see that, okay, this actual route is coming from the 1.1.1.1 that is generating by the router 1. So here is the use case of the router ID. So router ID, as I mentioned, that it's just a range of this one and it's just a name of the router. So you don't need to have a same IP address on the router. Take example, when you give the name to the any person, take example, there is a new baby born, right? So when you're gonna give the name to the new baby born, so you're not gonna ask to the prime minister, right? Hey, I'm gonna give the baby new name to the baby born. You just give the name. Same thing, we can just give the name of this router ID. Any name I can give that, but make sure that this router ID must be unique in the domain. If the unique will be not there, there will be a problem that we'll discuss. Don't worry about that. But yeah, this is the mix so that the name should be a unique name. So I can use the 1.1, I can use the 2.2, I can use the 3.3. I can use the 1.1 as well over here, right? There is no problem. But in future, you will see that some problem will be occurred. So just put the name as a unique right now, 2.2.2.2, 1.1.1, and 3.3.3. The election of the router ID, if I talk about, right? If I talk about the election of the router ID is a first preference, it will go to the manual, right? So you do have ability, you can define the manual router ID configuration. Manual router ID means what? Your network engineer has to go on the router and say that, hey, the router ID for this router is a 1.1.1, 10.10.10.10, or maybe the 200 or 200 or 200 or 200. That's the first preference. Second is what? If you don't define the manual, for example, if the network engineer has forget to define the router ID manually, then the highest loop back, right? IP address will become the router ID. If you don't have a loop back somehow, take example, then what happened? Highest physical, let me copy this one. Okay, why it's getting this one. So I'll just copy this guy and I'll paste it over there. So highest physical interface IP address will become the router ID. So if you don't have a loop back, then it will go for the physical interface. So this is the election criteria of the router. For example, you have a router over there, right? And this is the router 1. I just making that, and this router has a multiple loopbacks. Loopback 1 has a 1.1.1.1, and loopback 2 has a 2.2.2.2.2, right? At the same time, this interface also has a physical interface, this router. So let's take example, this router has connected with a different router, and this is the physical interface we have over here, 0/0. And this 0/ also have a IP address 10.1.12.1, right? Again, just any IP addresses. So if I'm just going to configure the router EIGRP or the router EIGRP, for example, then what happened in this case? If I'm going to configure the router EIGRP, I do have a first preference is what? Manual. I can simply say that EIGRP router ID will be what? 200 or 200 or 200 or 200. Again, as I mentioned that router ID is just a name of the router. Router ID is just a name of the router, nothing else. So it doesn't need that the same IP address should be there. So if you see that I don't have this IP address on the router right now, I just have a loopback 1 and loopback 2, and this IP addresses. I don't have a 200 or 200 or 200 or 200, but I still can give this name to this router. But take example, if you don't give this name, right? Take example, I'll just remove this guy, this command, EIGRP router ID, and I simply can say the exit right now, right? Then what happened? In this case, right, first manual will not take, right? Then it will go with the highest loopback interface IP address. So in this case, 2.2.2.2.2 will become the RID, right? Take example, if you don't have a loopback 2, then if you don't have a loopback 2, right, then what happened? It will go with the 1.1.1. And if you don't have a 1.1.1.1, right, take example, then what happened? The physical interface comes in the picture. So if you don't have a loopback, then it will go to the physical interface. And somehow, if you don't have a even physical interface IP addresses, right, then what happened? If you just put the command router EIGRP1, then router ID will be a 0.0.0.0.0, which is a reserved IP. So you cannot assign this router ID manually. This two router ID, you cannot assign it. This is a reserved one. You can only assign from the 0.0.0.0.1 to the 255.255.255.254. This is the range. You can use any range, but make sure that your router ID must be unique. So let's do some practical over there. So if you see that I have a topology with me right now, I have a router 1 and a router 2. So I don't have any IP addresses right now. So if you see, first of all, one thing, okay, what happened? Let me connect my, okay, that's my keyword is not working. So let's take example. I have router 1 right now, and I just say that config terminal. Let me first configure the any EIGRP routing protocol. If you see right now, do so IP interface brief, I don't have any IP addresses on this router. So what I mentioned that if you don't have a router, if you don't have any IP addresses, right? If you don't define manually, if you don't define the loopback, if you don't define the physical interface, then router ID will be 0 or 0 or 0. So if I'm say the router EIGRP, right? And I say the 1, that's my autonomous system number. And I say the exit right now. If you see the do show IP EIGRP topology, so the router ID will be 0 or 0 or 0 or 0. But you do have ability, you can assign them manually as well. For example, I can say that router EIGRP, let's go back router EIGRP1, and I can say that, hey, listen, EIGRP router ID will be maybe 200.200.200.200. See, if you one thing, I don't have this IP address on the router right now, but I can still define the router ID 200.200. Now, if you put the same command, do so IP EIGRP topology, I can see that the router ID has changed now. But let's take example. Let me remove the no router EIGRP and let's configure the proper IP addressing between router 1 and router 2. I say the router EIGRP. Sorry, let's define the IP address first. Interface 0/0. I say the IP address 10.1.12.1/24. Right? No shutdown, because by default physical interface is down on the router side. And then you have to say the interface loopback number 1. IP address will be loopback is my logical interface. Right? So you don't need to put the no shutdown command over there. And again, loopback doesn't have a MAC address. So this is the how that's we have done. Let's go on the router 2 right now. Router 2, if you see the router interface 0/0, I have a 10.1.12.2/24. And I'll just say the interface loopback number 1. I say the 2.2.2.2.2.2/30. And then, so now if I'm going to configure the router EIGRP, have a look over there, guys. If I say the do show IP interface brief, let me write down over here this thing. Router ID Alexa. The first, it will go with the manual. Second, it will go with the highest loopback interface IP address. Third is go with the highest physical interface IP address, right? So let's take example on router 1 side right now. I'm just say that router EIGRP. If I'm just going to put this command router EIGRP1, that's my autonomous system. And if I'm just going to press the enter, I haven't defined the router ID manually right now. Okay. And if you're going to say the exit right now, what happened? So I haven't defined the manually, it will go with the highest physical loopback interface, right? So 1.1.1 will become the router ID. So do so IP EIGRP topology. If you see, I have a 1.1.1. Right? Now, have a look. What I told you that router ID is just a name of the router. So if the router 1 has picked the 1.1.1 as a router ID, if I'm going to remove this loopback, no interface loopback number 1, simply, I said do show IP interface brief, right? My router ID is no more. Sorry, my interface is no more, but still I have a router ID. So again, router ID is just a name of the router, the same IP address, right? It's not mandatory to have a same IP address on the router side. Next thing, right? If you go on the router number 2, let me create the loop back, right? Because I want to extend the router with the EIGRP protocol. I say the 1.1.1 again back, right? And now let's go back to router number 2 right now. And what I can do that, I'll just remove the loopback number 1 from the router number 2 right now, just to show you behavior of the physical interface as well. I don't have a loopback right now. Do so IP interface on the router number 2. If you see, I just have a physical interface IP address, right? So if I say the router EIGRP1, that's my autonomous system number. And if I'm not going to define the router ID anything, right? What happened? I haven't defined the manually. I don't have a loopback. It will go with the physical interface. So do so IP EIGRP topology. The 10.1.12.2 is my physical IP interface, the router ID, right? if I'm going to create the loopback now, interface loopback number 1, and I say the 2.2.2.2.2, right? My router ID is not going to change. My router ID still will be 12.2. So do so IP interface brief, sorry, do so IP EIGRP topology right now. I still have a same router ID, 10.1.12.2. But if I'm going to create the another autonomous system number on the router number 2 right now, I say the router EIGRP number 2. In that case, if you see do so IP interface brief, what happened in that case? I just said the router EIGRP number 2, right? Now for this particular autonomous system number, the router is going to pick the router ID. So in that case, what happened? It will pick the loopback 1. I haven't defined manually. It will go with the loopback number 1. So if you see the do show IP EIGRP topology, as I mentioned that, one more thing, you cannot use the router ID. Like for example, let's go on router number 2 as the router EIGRP3, right? This is the new one. And I cannot define the router ID as a 0 or 0. And even I cannot define the router ID will be, but I can define the router ID like what? That's a starting range. If you see do so IP EIGRP topology, it's 0.0.0.1 for the AS number 3, or I can go with the, I can change this guy. Let me change this person, the last one. Now, same command is changed now. So that's a range you have, right? Let's do the advertisement of the protocol. So I'm just going to enable, so I'm just going to make sure that both the router have a EIGRP number 1, right? So let's go on the router number 1 and change this guy behavior. I'll say let me remove the router EIGRP and no router EIGRP 2, 1, and 3. So nothing is there right now. If you see the do show IP protocol summary, I don't have any protocol enabled. Even if you check on the router 1 right now, do show IP protocol summary, I don't have any EIGRP enabled over there. What I can do that, I'll simply go to router EIGRP and let's define the router ID manually, right? EIGRP router ID will be what? It's a 1.1. A very good way to define the router IDs manually, right? And same thing on the router number 2 right now. Router EIGRP 1 and router ID will be, right? Now what? Let's go on router 1 and say that advertise this route, network 10.1.12.0. Define the wildcard mask and network 1.1.1.1 and define the wildcard. Okay, so on router number 2 as well, on the network, I can say that 10.1.12.0, right? And I say that let's, even if you don't define the wildcard mask, that's fine. Okay, it's best practice to define the, even if I'm not going to define, it's going to work. They will form the EIGRP neighborship. And now I say the network 2.2.2.2. So what's the reason behind it? I define the wildcard mask that I will talk in the next video, right? We'll make a separate video for this guy. And now I say the network 2.2.2. Now let's find it. And now if you see that, if I'm going to put the command show IP EIGRP neighbor, I do have a neighborship, right? And show IP EIGRP topology, if I'm going to look for this particular route, because eventually what happened, router 1 is going to exchange this information with the router number 2, right? So if you see the do show IP EIGRP topology, right? 1.1.1, why not? Okay. So you can see that I got this information, this particular route. You can see that. And I'm sitting on the router number 2 right now. The use case of the router ID, you can see that. So I'm sitting on the router number 2 right now. I can see that, okay, this router I'm getting from the 1.1.1. That's a use case of the router ID, right? So network engineer, right, can, if they are going to perform the any troubleshooting, right, they can easily see that, okay, this route is coming from this person. That's originating means what? Who is generating this particular route. One more thing that I've talked about the route ID in the EIGRP case. So in EIGRP, normally what happened, right? Router EIGRP, if I'm going to make the 2, let's take example, if I'm going to make the 3, and if I'm going to make the 4. So if you see that I have run the 4 autonomous system number on the router 1 side. EIGRP number 1, EIGRP number 2, EIGRP number 3, and 4. So if you see that in this case, what happened? I just defined the manual router ID for the EIGRP number 1. I haven't defined the manual router ID for the EIGRP number 2, not 3, not 4. So if you see the do so IP EIGRP topology, right, what you will find that for this particular person, for the AS number 1, that's I have defined 1 to 1 to 1. That's a manually. For the remaining one, the 2, 3, and 4, I haven't defined manually. So what happened if I don't define the manually? It will go for the highest loopback interface IP address. So you can see that for the AS number 2, he took the same route ID, same route ID, and same route ID. So in EIGRP protocol, right? In EIGRP protocol, what happened? A router ID can be duplicate. In EIGRP protocol, a router ID can be duplicate. You can assign the same one. But if I talk about the OSPF, OSPF doesn't have the ability. So if you see the router OSPF, if I'm going to put the 1 right now, what happened? Exit do so IP OSPF include ID. It will take the 1 to 1 to 1 as a loopback. If I say the router OSPF number 2 right now, right, and I can put the ID, so it took the 10.1.12.2, right? That's an amazing one. So if I say the router OSPF 3 now, if you see this difference, right, and if I say the do show IP EIGRP include ID again, he said, hey, I cannot start the OSPF 3 process. The reason is that I'm not able to get the route ID. The reason is that because on this route, you just have a 2 interface, one interface 12.1, another interface 1.1.1. So for the OSPF number 1, what happened? The route ID has a 1.1.1. And for the OSPF number 2, the route ID is a 12.1. But I don't have any other IP addresses, right, on this router. So I cannot start this process 3. So in OSPF process, the route ID must be unique. The reason is that, right? The reason is that, let me show you this thing as well. So what I can do that, I'll just go on the router number 2 right now, and I'll say that router EIGRP number 1. I'll make sure that EIGRP router ID will be what? 1 to 1 to 1. And now if you see show IP EIGRP neighborship, first I'll show the show IP EIGRP topology include ID, right? I can see that for the router number 1, the router ID for the EIGRP is what? 1 to 1 to 1 to 1 to 1. And for the EIGRP number on the router number 2, for the EIGRP, it's also a 1 to 1 to 1 to 1. And if you see the neighborship, so IP EIGRP neighbor, I still have a neighborship with the same route ID. So there is no issue. Yeah, there will be some issue that I'll talk in the next video because I don't want to make this video as a long. I'll make a separate video for this guy. Why? What is the reason behind it? Right. But yeah, we do have a neighborship. But if I'm going to run the same OSPF protocol, let's do that. I'll say the router OSPF 1, right? Let me remove all the OSPF process from there. And I don't have a 3 right now. So I'll say the router OSPF 1. So the router ID will be what? So there's a different command in that you can see that. Okay, let me remove the 3 first of all. Router OSPF 1, router ID will be 1.1.1. Right, I said the network is what? 10.1.12.0. Let me define the wildcard mask, area 0. And same thing on the router number 2 right now. I said router OSPF 1, and I said router ID will be what? 1.1, same router ID. Not a big deal, right? 10.1.12.0. And I said that 0 to 255, area 0. If you see that, what happened? They will not form the neighborship. Because in a OSPF perspective, what I did, in a OSPF, I just defined the 1.1.1 as a route ID and OSPF 1.1.1 as a route ID. So if the router ID is same in the OSPF protocol, right, they won't form the neighborship. He said, hey, I got the duplicate router ID now from the 12.1. Duplicate router ID means what? I'm getting the duplicate router ID 1.1.1 from the 12.1. So R2 is saying this thing. 12.1 is my router 1. So it means that on my side is also running with the same route ID. So I cannot form the neighborship, but I do have a neighborship with the what? I do have a neighborship with the EIGRP. So you see that do show IP EIGRP protocol neighbor, do show IP EIGRP neighbor. I do have a neighborship, but I don't have a neighborship with the OSPF. Right? That's a difference is that in the EIGRP and OSPF router ID, right? Election criteria is same. the manual, highest loopback, and highest physical interface. OSPF won't form the neighborship if you have a same route ID. EIGRP will form the neighborship if you have a same route ID. The use case, if I talk about, right, the route ID use case, it's not only to identify the router, right? In some protocol, OSPF route ID is also used to prevent the loop. So for example, EIGRP does this thing. We'll discuss this thing in the next video. Yeah. So router ID is not only for to identify the router, it's a use for the prevent the loop as well. So in OSPF, what happened? They are not forming the neighborship. In EIGRP, they are forming the neighborship. Even if you have a BGP, in this case, in the BGP also, they will not form the neighborship. BGP also need a unique IP address, unique router ID. Another thing that I want to show you over here, if you see, I just saw that router OSPF 3, right? So when I create the multiple router EIGRP, let me show you this thing as well again. So I say the router, let me remove the OSPF from there now. Just for right now, I say the router EIGRP 1, router EIGRP number 2, router EIGRP number 3, router EIGRP number 4, 5, or maybe 4 as well. So I have defined the 5 EIGRP process ID, right? Same thing, let's define the router OSPF 1, router OSPF number 2, and router OSPF number 3. It will throw the error message. The reason is that if you see, do so IP EIGRP topology, include ID, and do so IP OSPF, include ID. If you see that, what happened, I am able to run the 5 AS number, right, for the EIGRP. I have a same route ID for each AS number because duplication is allowed in the EIGRP, but in the OSPF, it doesn't do that. The reason the OSPF 3 is not started because OSPF is a pure IP-based protocol. It's a pure IP-based protocol. Again, EIGRP also is an IP-based protocol. EIGRP works on the protocol number 88, right? Whereas this one, the OSPF is 89. So if you see the Wireshark capture as well, let me show you that. Come on. Yep. So OSPF is a pure IP-based protocol. Let me show you the some OSPF packet, or maybe the EIGRP. Yeah, I do have a EIGRP as well. So if you see the EIGRP is a 88 protocol number, it's a layer 3 protocol. And same way, OSPF, you see that it's 89. It's also a layer 3 protocol. But only the difference is that OSPF is a pure IP-based protocol, whereas the EIGRP is a IP-based protocol. But at the same time, in the older days, right, EIGRP does support the IPX and Apple Talk as well. That's why, right? And another reason is that the router ID concept, right? If you see the EIGRP hello packet, in EIGRP hello packet, if you see that, we are not sending the any router ID information in the EIGRP, right? But in the OSPF, if you see the OSPF hello packet, we are sending the router ID. Right? So that's the reason OSPF doesn't form the neighborship if they have a duplicate route ID, and EIGRP does form the neighborship. The next thing, right? Let's see how to allocate the router ID with in BGP protocol. So if you see, I say the router BGP right now, and I say the BGP router BGP1, and I do have it. I say the BGP router ID what? That's a manual configuration. I say the 1.1.1. That's all. So do so IP BGP. Or I need to form the neighborship. I think so. It won't show the information over here. Yeah. It doesn't show the information. All right, let me do the neighborship forming. So I said the neighbor will be 10.1.12.2. I said the remote AS will be what? It should be 2. For example, I'm just using this guy's a AS number 1 and this guy's a AS number 2, right? So same way on the router number 2 right now. Let's go it. And so router BGP number 2 right now. I said the BGP router ID will be 2.2.2.2 manual configuration, right? 10.1.12.1, and as the remote AS will be 1 now. And just wait for some time because BGP just slow down in protocol. So you need to have a good patience, right? So IP BGP neighbor, you can see that if you go above, That's my remote route ID. So on the router number 2, if you're sitting over there, right, you can see that my neighbor is using the 1.1 as a router ID. And if you check on the router number 1, so router 1 will say that neighbor, so IPBGP neighbor, he will say that, hey, my neighbor is using the 2.2.2.2. So that's how the use case of the router ID, guys. So in this video, we have talked about the router ID concept in the EIGRP perspective, OSPF perspective, and the BGP. I just give you the basic information about the router ID. Router ID is again 32-bit number, right? The definition, defining of the router ID format is a x.x.x format. The 0.0.0.0.0 and 255.255.255.255, it's a range, but this two IP is a reserve. So you can use this from this one to this one. So from here to here, not 255.255.255.254. So you can use this range. You cannot use this 2.1. This is reserved one, right? And the format of the route ID, we have seen that it's a different way. So let me mention this thing as well as, so also just show you the command line so that the video will not take so long. So section router. So every routing protocol has a different command line to define the router ID manually. So if you see that EIGRP has a starting with the EIGRP router ID, that's a format to define the router ID in the EIGRP. In BGP, even if you see that we have a same like a method, I just need to put the BGP here. I just put the EIGRP and then router ID, router ID. But in OSPF, it's a little different. In OSPF, you just need to say that what. So the router OSPF number 5. If you see, he will throw the error message because I don't have any IP address to allocate him. Because I just have a 2 IP address. If you see that, I just have a 2.1, right? So we have already allocated this to OSPF, this 2 IP addresses to the different OSPF. If you see that those IP OSPF include ID, I have already allocated that. So I don't have any IP address for the 5. So what he's saying, I read this message, OSPF process 5 failed to allocate the unique route ID, cannot start. Let me big it. It has to show the more information. Let me create another one, router OSPF 6. I'll show you the complete log message. It's not showing that in this one. So if you, I think so my is a different version to so version include iOS. It's a 15.2, right? If you check in the other iOS version, it will show you that hey, same message will be there, but after that there will be another message. He will say that hey, you can manually assign the route ID. So if I'm going to manually assign the route ID for this guy, if you see that this is the command to allocate the route ID in the OSPF. So I can say that hey, let's give the 200 or 200 or 200. I don't have this IP address, but I can allocate it. Now the OSPF 6 will work. So previously this output command was showing only this 2 process. Now if I'm going to put the same command, it will show me the 6 as well. So that's how you can define the route ID in the EIGRP, OSPF, and BGP protocol. MPLS also has a route ID, but that route ID is totally different. In our, we have seen that the route ID size is a 4 byte, right? 4 byte means what? It's 32-bit number. That's a x.x.x.x. IPv4 format. But in MPLS, we don't have a router ID concept. We have LSR ID because a router is known as a LSR router, and where the router ID size is 6 byte. The LSR ID is just 6 byte. So we'll make a separate video for this one. Okay. So I hope you have enjoyed this session. Thank you so much. See you in the next video.